Everybody, you're in South Seas ABE. Our next talk is Samsung Pay, Tokenized Numbers, Flaws, and Issues with Salvador Mendoza. I got a couple of quick announcements here. Stop by the business hall on the first level in Bayside AB if you haven't done so already. There's a lot of great vendors in there. The Black Hat Arsenal is in the Palm Foyer on level 3. That's the level we're on, over by the escalators. Definitely some good stuff to check out there. And there's also a reception in the Arsenal at 1700 this afternoon. If you haven't picked up your merchandise today, the Black Hat Swag and Bookstore, today's your last chance to do that, so definitely check out what they've got. And if you don't mind, if you haven't already, please put your phone on silent so it doesn't interrupt the presentation. Thanks a lot. Salvador?
Thank you. Good morning, everyone. I know it's early for a talk, but it's my first time in Black Hat, so I'm very excited. Hope it's the first of many. Today I'm going to talk about Samsung Pay, tokenized numbers, flaws, and issues. So let's start with the agenda for today. I'm going to talk about terminology, analyzing tokenized numbers, also about near-field communication protocols and magnetic security transmission protocol too. Token phases or status, of course, flaws and issues. That's why we're here. Dangerous scenarios, international tokens, and introduce you the Jam Pay tool. So let's start with the terminology. We are going to have NFC for near-field communication, MST for magnetic security transmission, BTS for Visa Token Service, which actually are the rules for the tokenization process. Tokenized numbers is where a process where the primary account number is replaced with surrogate data, a value in this case, which is equal a token. And a token is a voucher to interchange for goods or services. TSP for token service provider, which are in charge for to validate tokens, and the PAM for primary account number. So let's start for analyzing tokenized numbers. Basically, when you're going to make a payment with Samsung Pay generate 3 tracks. It's very similar, or it's the same thing like when you swipe your card in the terminal. The main difference is like every token is equal in all the tracks. It doesn't matter what track the terminal detects. If it detects any of these ones, the transaction can go through. Let's analyze the last part of the token. Basically, are 20 digits. You need to analyze this token like they are different counters and the last 20 digits. The first 4 are for the new expiration date. The next 3 are for the new service code. Basically, you have a chip and PIN protection card, and you add it to Samsung Pay. Samsung Pay is going to change the service code to be used so you can use your card without necessity to have a physical card with you to make a purchase. The next 6 digits, I call it transaction range, which plays a CB role. The next counter is a transaction ID, which increases +1 every time you use Samsung Pay. The next 6 digits random numbers to fill the American Banking Association format, generated for a cryptogram or I method. Let's talk about the offline-online mode. Basically, when you can use your Samsung Pay to make purchases even in airplane mode, which means Samsung Pay doesn't have a full control of the tokens. But when you are using an airplane mode, the counter in the middle is constant. It never changes. I call it provision token, which means it's not connected to a server yet. However, when the Samsung Pay connects to the internet, the counter in the middle will change +1 sometimes every 3rd or 5 transactions. So in offline mode, what I said, you can make purchases in offline mode. Token phases or token status. Basically, like any other transaction or like another card, these tokens go to a process where it could be impending, active, disposed, enrolled, expired after a period of time. The main idea of the token is like if you use one token, you cannot use it anymore. It's like an ID for a database too. How Samsung Pay could update these tokens? Basically, it connects to a sandbox using a provision token ID. You need to keep in mind this slide because we're going to use it later. And also, it has an API key to make these changes in the token using a JSON format. We're going to talk about some file structures. I found that Samsung Pay implements more than 20 databases and directories and files. All of this kind of information is for transactions, for encryption, to encode information, and also to connect or save logs. Basically, all lies to Samsung Note security. For example, you try to root your phone, Samsung Notes will detect that you root your phone, and you cannot use Samsung Pay anymore. Let's talk a little bit about this database in the bottom, CVP Jan Encryption DB. Let's see the structure of this database. What we can see here, so is some of the kind of very important information: a provision token ID, app program ID, VPN enrollment ID. Some of this kind of information could be used to update the token status. What I found very interesting is if an attacker could find a way to update the token status, he or she doesn't have the necessity to get another token. He can update the token status all the time. Maybe you're thinking the encryption of these databases are very secure. Well, what I found was that the function to encrypt these databases uses static passwords. So the main idea here, it really is an encryption method, or is a static substitution characters. Also, what I found interesting is not just one method implements this function. Many of the methods in Samsung Pay implement this method to encrypt, in this case, the data. Another flaws and issues is when you add your card to Samsung Pay, it keeps you in a range. What I mean with that? I mean that if you delete your card for any reason, maybe you're suspicious that someone captured a token, and you delete it and add it again, the new virtual credit card is almost similar or equal, almost just the 4 last characters are different. I tried to delete and add it from different dates, and I found that it doesn't matter when you delete it and when you add it, you are going to find almost a similar card, virtual credit card in this case. Continue with flaws and issues. Token expiration date. I have the possibility to back up the data from Samsung Pay one day. Now it's impossible because they restrict it. But what I found interesting, the token expiration date wasn't blank in one of the tables. The table was the card. And the retry expiring time implements timestamp format, which was just for one day. So I found that if Samsung Pay generates a token, but it's not used to make a purchase, that token is still alive or still active. For example, if you have a friend and he asks you, hey, can you show me how Samsung Pay works? And he opened the application and started making a transaction, that token is not going to be available to make a purchase with that again, but that token is still alive. So let's talk about the scenarios. One attacker could reverse the encrypt at the decrypt function, social method, but also the jamming MST signal. The last one is guessing the next token. Could be possible. About the encrypt at the decrypt functions, at this point, it could be an attacker because the attacker could decrypt the reverse these functions and to get information not just for the Samsung Pay by itself, but for the connection too, probably. If Samsung Pay implements the same function to encrypt the data on the network. Let's show you a video about social engineering. I was talking about it. So basically, if someone asks you to show how Samsung Pay works, and he has a device to capture a token, he will be able to get a token and use with another hardware to make a purchase. In this case, I use this hardware to send by email the token. So I got it in the background. So after that, I use a Mac spoof from Sammy Camcar. Thank you, Sammy. You're my hero. And now I can use it to make a transaction using that token. So it's a very cheap device to capture a token, also a cheap device, the max spoof, to make a purchase. So let's talk about JamPay. JamPay is the tool I'm introduced today. It's a very basic tool using a Raspberry Zero, LiPo 5 volts, credit card reader for one hit, max spoof, and all the connections. These kind of dimensions. So I have a video for these two. Let's imagine that we're in the Vegas. And we have many different people that are walking in the streets. And they say, I'm going to use my Jam tool in Vegas. So I'm going to start sending signals to the terminal to Jam, in this case, the signal of Samsung Pay. I start making a payment. But I didn't notice that the JamPay is receiving the token and sending by email. So I got the token. After that, I use MaxSpoof to use that token to make a purchase. So basically, this is one of the attacks that I'm to introduce today, using a jammer. Basically, it's authorizing the purchase. And yes, you select drink because it got through. And it's vending. So I'm going to skip this one. Well, let me try to this one to see how Samsung Pay implements the tokens. What I'm going to do is I'm going to capture tokens using my card. Please don't use it in real world. So this one is one token. This one is another token. If you see right here, this one is the transaction ID. These numbers never change. Well, it will change eventually after 3 or 4 transactions. Let me make another transaction. However, every time you open your Samsung Pay, the last token, you cannot use it anymore. So you can see the difficult to guess the next token. It could be the last 4, 5 digits. So let's continue this one. I have international Samsung Pay tokens. I was wondering how we can use the tokens. And I asked one time Sammy Kamkar, he was able to use one of my tokens in South California. He said no. However, after I finished my research, I asked one of my friends in Mexico if he can use one of my tokens in Mexico to see if the transaction can go through. Basically, Samsung Pay is not in Mexico yet. So I sent one of my tokens to my friend. It was, I think, last month. It was July 8th. So I sent one of my tokens, and I say if he can make a purchase or try to make a purchase in Mexico. He tried to charge me 20 Mexican pesos. And basically the transaction went through. So I was wondering, what are the restrictions for these kind of tokens? If they have the same restriction like just physical credit card, or it's a different kind of restrictions. So he made a payment, and I got the Mexican pesos in my Samsung Pay notification. Oh, damn. So, what we learned today was Samsung Pay has some levels of security, but it's a fact that could be targeted for malicious attacks. Samsung Pay has some limitation in the tokenization process, which could affect customer security. And finally, token generated by Samsung Pay could be used in another hardware. Please, if you have any questions, feel free to go to the microphones, and I'll be happy to answer. Go ahead.
Hi. Before you do the payment, you still need to do fingerprint scanning.
Sure.
So without it, really, it's hard to activate it.
Basically, it depends. Of course, you need to, if an attacker, the attacker is going to try to intercept the MST signals. The MST signals, basically, it's the token by itself. So if the attacker can get the token, he can make a purchase. It doesn't need any another kind of security. It doesn't have any restriction, the token, to make a purchase, basically. So, yeah, but the user has to make like a transaction to deliver the token in this case.
You said there was a change made that prevents you from reading the tokens out from within the phone itself. Does that mean that this is going to rely on having physical access to intercept the token, and that a software attack is probably not practical?
Basically, yes. The attacker has to be close, in this case to the cell phone, to get the MST signals. We are talking about close to 2 inches. Without that range, it would be impossible to intercept the MST signals.
Have you heard of anybody making skimmers yet for these readers?
I don't know yet. I don't know yet. Thanks.
Since your JamPay device is offline, have you tried doing consecutive purchases with it, and how many did you actually succeed with?
I tried with all my cards. Basically, what I did was I tried with different banks, and every token that I get, I could use it to make a purchase.
But with that one token, how many times can you make another purchase?
Just one. Just one. Basically, every time you use your token, you can't use any more.
Even though it's offline, because you talked about how offline tokens can be reused.
Even offline. Okay. Because I think the server has a function to know which token is going to be continuous.
Yep. Hi. Did you have any contact with Samsung, and was there any vendor response about this?
Yes, we were talking about 2 months now, and yes, they are working on it. They are making updates. Yes, basically yes.
Just a question: the encrypt decrypt that you described, is it something that's using trust zone, or you said it can be attacked? Or how you can get the token? Is it stored just in database available in the Android, or?
The main point is like when you're making a purchase, the cell phone is sending MST signals, and that MST signal you can convert to characters, which is like magnetic transmission. So you need a device. In this case, I use a credit card reader. So with a credit card reader, I can get this data and send it to my Raspberry Zero, and the Raspberry Zero sending that data to my email, and so I can use it in another hardware.
Okay, thank you.
That's the process.
Have you tried doing something similar with Apple Pay or Android Pay?
The main difference is like Apple Pay and Android Pay use NFC protection, encrypted protection, which means even if you get the tags to make in this case, an attack, you need a cryptogram, okay, which is kind of impossible to make an attack. There's anyone else? Please feel free to contact me if you have any questions. I would like to respond. Thank you very much.